Namaste. Before starting the classes, I want to explain two corrections in the previously discussed chapters. One was in equilibrium. I think question number 9. 4 reactions regarding the decomposition of oxides of nitrogen were given. And the question was, which is the stable oxide? Okay. If it is formation of the oxide, my explanation was correct. Okay. Suppose nitrogen and oxygen combine together to form a particular oxide, and equilibrium constant of that reaction is high, means product side is more stable. Since it is the decomposition of oxide, lesser the value of the equilibrium constant, more will be the stability. And that was the first correction. And some of the students asked me personally what was the strength of hydrogen peroxide per hydrol. It is 30% 100 Vs. I am not remembering what was the options. Okay. Anyway, per hydrol, it is used as a mild antiseptic. Per hydrol, it is 30% hydrogen peroxide or 100 Vs. Okay, that is the answer. I am not remembering what are the options. So these are the two corrections requested by some of the students. Okay, so these are the corrections. Actually, the students who are correctly observing it. Okay, congrats. Okay, keep going on the same thing. Okay, when we are discussing totally, maybe there are some variations. Okay, if you are very eager to see it, that means you are on the right track. Okay, congrats once again. Today we are going to discuss organic chemistry, because I am skipping S block and P block. In organic chemistry, it is you have to thoroughly by heart NCERT. That is only one method. There is no problematic side in inorganic chemistry. Only the equations that you have to by heart. So S block or P block, if time permits, we can do in the last session. Now we are directly entering to organic chemistry. Organic chemistry first year is the basic concepts connected to naming, then some reaction mechanism side, then purification, characterization, like that. So directly I am entering to the questions. First questions that is already with you. An organic compound containing nitrogen, sulfur, oxygen as extra element fused with the metallic sodium, extracted with water. That means we are dealing Lassane's extract. The question, the species that is not present in the solution. Okay. 4 options were given: CNS minus, CN minus, S2 minus and NO3 minus. You find the answer, I will tell you. In organic chemistry, all atoms are connected by covalent bond mutually. And in the laboratory, we are using some testing agents which are purely ionic in nature. So ionic species cannot easily react with a covalent molecule. So first of all, we have to withdraw that covalently bonded atoms like nitrogen, sulfur, etc. Okay, and make them ionic. So for that purpose, we are boiling it with or melting or fusing it with a metallic sodium. Whenever sodium combines with any of the atom, the compound formed is distinctly ionic in nature. Ionic compounds can be easily tested. Okay, so while preparing Lassane's extract, see, organic molecule may contain nitrogen, sulfur, chlorine, bromine, iodine, phosphorus is also there. That is entirely different. If nitrogen is present, that is normally converted to NaCN. This is to Na2S, this is to NaCl, this is to NaBr, and this is to NaI. And one more, if Na and S together present, that is converted to NaCNS. Na plus CNS minus, Na plus Cn minus, Na plus S2 minus, Cl minus, Br minus. Okay. So these are the conversions happen when we are preparing Lassane's extract. So I explained the theory, you just find the answer and tell me. Question number 1. Number 2, blue color, continuation. Blue color in, actually it is not blue color, Prussian blue color, formed in the positive test for nitrogen. This Cn minus can be tested by adding some freshly prepared ferrous sulfate and then acidify with the sulfuric acid. You are getting a Prussian blue color. What is the formula of that compound? It is directly given with the equation. You have to study that equation also. Fe for Fe, CN6 size, ferric ferrocyanide. Option is there, number 1. 0.2 gram of an question number 3. 0.2 gram of an organic compound containing phosphorus gave 1.877 grams of ammonium phosphomolybdate as by usual analysis. Percentage of the phosphorus. Carrier's method, that is the name of the method. Carrier's method, that is used for estimating the presence of sulfur, chlorine, bromine, iodine, okay, phosphorus also. The formula in Carrier's method, phosphorus percentage is equal to 31 divided by 1877 into weight of magnesium, what is that compound? Not magnesium, ammonium phosphomolybdate. If it is magnesium pyrophosphate, there was another formula. Okay, ammonium phosphomolybdate divided by weight of organic compound into 100. That is the formula. So 31 divided by 1877 into the weight of ammonium phosphomolybdate is given as 1.877. Easy to solve. Divided by compound weight, it is around 0.2 into 100. Solve it and find the answer. It is very easy. Can be easily cancelled. So one more formula is there. That is for percentage of phosphorus in another method. It is 62 divided by 222 into weight of magnesium pyrophosphate Mg2P2O7. Okay, divided by weight of organic compound into 100. That is another formula. Okay. If you know the formula, you can easily solve it. That's all. Question number 4. The most stable carbocation among the following. Given options contain primary, secondary, tertiary. Among primary, secondary, tertiary cations are more stable. So option 4 is the right answer. Question number 5. Ammonia evolved from the treatment of 0.3 gram of an organic compound for the estimation of nitrogen was passed in 100 ml of 0.1 molar sulfuric acid. Excess of the acid required 20 ml 0.5 molar NaOH for the complete neutralization percent of nitrogen. The method is Geldahl's method. But in Geldahl's method, there are some restrictions. Some of the functional group nitrogen cannot be estimated. You refer it. I told you in the normal class. What is the formula for finding percentage of nitrogen in this method? Percentage of nitrogen is equal to 1.4 NV by W is one formula. N is the normality of the sulfuric acid taken, V volume of sulfuric acid consumed, and weight of organic compound. Here the question is in molarity, so you have to multiply with 2. So 2 into 1.4 valency multiplied with valency. 2 into 1.4 into M divided by weight of organic compound into volume of sulfuric acid consumed can be split as V1 minus V2 by 2. Why? Because as per the given data, they are not giving the consumed volume of sulfuric acid. They are giving volume of the NaOH and volume of sulfuric acid. Originally there was some sulfuric acid. Okay, after passing ammonia, you know the method, Geldahl's method. In Geldahl's method, complete nitrogen is quantitatively converted to ammonia. Last step you are getting ammonia. And you have to find the volume of ammonia, but unfortunately ammonia gas cannot be collected by the downward displacement of water. In Dumas method, we are converting complete nitrogen into N2 gas. That N2 gas volume can be easily measured because it can be collected by the downward displacement of water. Volume can be easily measured, but here it is not possible. So we are using an indirect method. First of all, you have to pass ammonia into a non-excess volume of sulfuric acid. After the neutralization, okay, some sulfuric acid left behind. That is why we are taking excess sulfuric acid. So remaining sulfuric acid is estimated by titration with NaOH. Agree. So that type of data is given in the question. So instead of direct V, volume of sulfuric acid consumed, original volume of sulfuric acid taken, volume of NaOH required for titration. So V2 by 2 represents remaining sulfuric acid. So from the original volume, when we are subtracting remaining volume, you are getting consumed volume. So these are the data given as per the question. So I am just substituting. You find the answer. 2 into 1.4 divided by weight of organic compound is given as 0.2 gram, not 0.2, 0.3 gram into molarity of sulfuric acid, that is 0.1, into 100 is the volume of sulfuric acid, minus. There is a problem in the molarity of NaOH because it is 0.5 is given in the question, but the sulfuric acid is 0.1 molar. So you have to make it uniform. Okay, you have to make it uniform. So 20 ml 0.5 molar NaOH. I am converting this 0.5 to 0.1 molar. So concentration become 1 by 5. So automatically volume become 5 times means it become 100 ml. So instead of 20 ml 0.5 molar, we have to take it as 100 ml 0.1 molar. So instead of V2, again 100 by 2. So 50 minus 50, 100 minus 50, 50. So 2 into 1.4 into 0.1 into 50 divided by 0.3. You tell me the answer. Okay. Okay. So that is Geldar's method. You find the answer and tell me. Question number 5. Then question number 6. A compound given in a linear pattern, you have to find the IUPAC name. Easy question. I am writing the formula. Is that clear? Remember the formula, these two formulae. Okay. Molarity of the sulfuric acid consumed, weight of organic compound V1 minus V2 by 2. V1 is original volume of sulfuric acid. V2 is the volume of NaOH required for titration. V2 by 2 is the consumed volume of sulfuric acid. Now the compound, organic compound. See. Now. CH3, CH2, CH. CH3, CH2, CH. And that CH within bracket they are giving CH2, CH3. That means it's a branch. Again, CH2C, CH2C contain CH3, CH3, and again next one is CH2, CH3. So this is a compound given, you have to find IUPAC name. See, 1, 2, 3, third position carries 2 methyl group, 1, 2, 3, third position carrying 1 ethyl group. So what will be the rule here? Suppose here there is only one methyl group. Imagine here there is only one methyl group, then you have to start numbering from left to right. Why? Because third position methyl, third position ethyl, so alphabetically priority goes to ethyl. But here it is not the situation. Here there are two methyl group and here there is only one ethyl group. So select the direction in which maximum number of side chains are getting minimum number. Maximum number of side chains are getting minimum number. Okay, so numbering should start from right to left. So 1, 2, 3, 4, 5, 6, 7 means 5 ethyl, 3, 3 dimethyl heptane. 5 ethyl, 3, 3 dimethyl heptane. You find the answer that is given in the option. I think it is 4. 5 ethyl, 3, 3 dimethyl heptane. 7th question, chain isomerism possible for the molecular formula C5H12. Chain isomerism possible for the molecular formula C5. C5H12 means pentane. Pentane, the chain isomers only 3. Normal pentane, 1, 2, 3, 4, 5. Isopentane and neopentane. That's all. Okay. So answer 3. 3 isomers, chain isomers 3 are possible for pentane. Okay, I am extending the same question for you. Suppose C5H12 pentane, how many monochloro derivatives are possible for this molecule? How many monochloro derivatives are possible? That means in this particular option, normal pentane, isopentane and neopentane, suppose we are substituting one chlorine, how many options are possible? Suppose I am placing one chlorine here. Imagine this is called 1 chloropentane. Here also it is called 1 chloropentane. That means these two locations are same. Suppose I am placing one chlorine here, it is called 2 chloropentane. Here also it is called 2 chloropentane. These two are identical. And when I am substituting here, it is called 3 chloropentane. So from this molecule itself, how many isomers are possible after monochloro substitution? 3. And here, suppose I am placing a chlorine here, 1 chloro 2 methyl butane. 1 chloro 2 methyl butane is the basic chain. Suppose I am substituting here one chlorine, 1 chloro 2 methyl butane. That means these two locations are same. Agree? Imagine 1 chloro, 1 chloro. So these two locations are same. Suppose I am placing a chlorine here, it is called 2 chloro 2 methyl butane. 2 chloro 2 methyl butane. Suppose I am placing here 2 chloro 3 methyl butane. And here 1 chloro 3 methyl butane. That means how many options possible? 1, 2, 3, 4. So 4 isomers are possible for this one. Okay, and for neopentane there is only one option. When I am placing here 1 chloro 2,2 dimethyl, when I am placing chlorine here 1 chloro 2,2 dimethyl, that means all the carbon atoms are equivalent here. So this molecule can form only one. So after the monochlorination, how many isomers are possible? The answer is structural isomer. I am not talking about stereoisomer. that is different. Structural isomers, okay, possibility, okay, 1 plus 4 plus 3. That is an extension only. Next one. Question number 8. Heterocyclic compound among the following. Heterocyclic means other than carbon you have to see any other atom. Cyclohexane contain only carbon, cyclohexene also contain only carbon, cyclopentane also contain only carbon, tetrahydrofuran, that is given in the NCERT, furan. Heteroatom is oxygen. Agree. Next. IUPAC name of the compound. A compound given to you and find the IUPAC name. And I will draw the figure. What is IUPAC name of this molecule? See, it's a cyclic compound, so you have to select the parent part as the cyclic chain in ring. And here in this particular molecule, which is the more prior part, is it side chain or double bond? It is double bond. So you have to start numbering from the premises of double bond. Okay. Suppose I am numbering from here 1, 2, 3, 4, 5. Fifth carbon and sixth carbon carries side chain. Suppose I am writing in the anti-clockwise direction 1, 2, 3, 4. Third and fourth. So minimum number is in the anti-clockwise direction. So 1, 2, 3, 4, 5, 6. So the name of the molecule is 4-ethyl 3-methyl cyclohexene. Okay. Ethyl comes first alphabetically. So 4-ethyl, then 3-methyl cyclohexene, option 3 is right. Agree? Question number 10. Here also a compound given to you. Okay. The compound is CS3, CH, OH, CH double bond, CH single bond, COH. A molecule containing OH, COH and double bond. 3 functional group. I will give the clue, you find the answer. This type of questions we have discussed in the class a lot of. In this molecule, which is a prior functional group, COH. So start numbering from COH carbon. So 1, 2, 3, 4, 5. And the fourth carbon carries an OH group. And inside the parent chain there is a double bond. Okay, so name of the molecule should end in oic acid. That is a main rule. Agree? Then you find and tell me the answer. Okay, next one. Plus R effect or plus M effect, mesomerism or resonance, both are same. Okay. Plus M means participate in resonance by giving electron. In organic chemistry, we are mainly dealing benzene as the resonating system. And we know so many functional groups. When a functional group is connected to benzene ring, it will participate in the resonance of benzene either by giving electron or by taking electron. If it is giving electron, called plus M or plus R. If it is taking electron, called minus M or minus R. Okay, I am not giving the answer to you. You find and tell me. 11th Cn minus is the CHO is the Cn not minus Cn, CHO, COH and NH2. Okay. Next, Liebig's method for the estimation of carbon hydrogen. 0.5 gram of an organic compound gave 1.76 grams of carbon dioxide and 0.72 grams of water. What is organic compound? So in this method you have to find the empirical formula, then only you are getting an idea about the compound. So before reaching that empirical formula, first of all you have to find percentage. So make this question by practice for practicing Liebig's method. You know, carbon and hydrogen, that is normally estimated by Liebig's method, and here also I am giving some formulae. See, percentage of carbon, percentage of carbon 12 by 44 into weight of carbon dioxide divided by weight of organic compound into 100. Percentage of hydrogen is given by the formula 2 by 18, 1 by 9 into weight of water divided by weight of organic compound into 100. So these data are given. Weight of carbon dioxide is given to you. Okay. Similarly, weight of water is given to you. So using the data, first of all you have to find the percentage, then only you can reach to the empirical formula. Agree? So I am substituting weight of carbon dioxide. What is the weight of carbon dioxide? 12 by 44 into weight of carbon dioxide given is 1.76 divided by weight of organic compound is 0.56 into 100. And here 2 by 18 into what is the weight of water, 0.72 divided by 0.56 into 100. The answers of this question comes around 85 point something, 85.6 or 7 like that, and the next one comes around 15.4. So these are the respectively percentage of carbon and hydrogen. Okay, you can proceed only after getting this answer. Then next you have to find empirical formula. I'll tell you the method: carbon and hydrogen. So 85.6 you have to divide with its atomic mass 12. 15.4 you have to divide with the atomic mass 1, and 85.6 divided by 12 comes around how much? It is coming around 7 point something, around. What is 12 into 7? Okay, it is around, not exactly, and here 15.4 itself. Okay, so answer is least here. Here answer is 15.4, here answer is 7 point something. So you have to divide all the answers with a 7 point something. So here become 1 and here become 2. So the empirical formula is CH2. That means number of hydrogen atom is double the number of carbon. Number of hydrogen atom is double the number of carbon. So in the option you have to select one answer in this particular pattern. Okay, we have to avoid oxygen containing answer. Only two answers, C6H6 and C4H8. So probability C4H8. Okay, so remember these two formulae also. Liebig's method, how to find percent of carbon and percentage of hydrogen. Next, Dumas method. I told you nitrogen can be estimated by Dumas method and Jelzal's method. Dumas method, for the estimation of nitrogen, 0.3 gram of an organic compound gave 50 ml nitrogen collected at 300 Kelvin, 715 millimeter of mercury pressure. Aqueous tension is given, percent of nitrogen. What is the formula in Dumas method? Dumas method. Listen. See. Percentage of nitrogen is equal to 28 divided by 22,400 into volume of N2 at STP, collected at STP, divided by weight of organic compound into 100 is the formula. Okay, but in this question, nitrogen volume is not given in STP. They are giving at 300 Kelvin and 715 pressure, millimeter of mercury pressure. So that is the problem here. We have to convert that volume. The volume given is, how much is the volume given? 50 ml. That 50 ml you have to convert into STP. So use the formula from states of matter. P1 V1 by T1 is equal to P2 V2 by T2. I am taking this one condition as STP. So pressure at STP 1 atm. V1 we have to find, temperature is 273. This is equal to P2, the given pressure. Yes, there is a trouble. Aqueous tension is given. See, what is 1 atm? I am changing to 1 atm 760. Since it is given in millimeter of mercury. Okay, 760 into V1 divided by 273 is equal to P2. P2 means the pressure, given condition pressure is 715. Listen, there is a point. Whenever aqueous tension is given, whether it is a problem from states of matter or from thermodynamics or here, aqueous tension, you know what is the meaning? Normally gases are collected by the downward displacement of water. So when water is displaced and gas is collected above it, normally that gas is mixed with some water vapor. Okay, so in that situation, the pressure measured is not only the pressure of the gas. Okay, it contains the pressure executed by water vapor also. The pressure given by water vapor is technically called as aqueous tension. So 715 is the pressure measured here, and actually that is the sum of the pressure of the dry gas plus aqueous tension. So you have to subtract that aqueous tension, then only you are getting the real pressure. Agree? So 715 minus 15. So 715 is the value and 1515 is the pressure of water vapor aqueous tension. So 700 into volume given measured is 50 and the temperature is how much? 300. So from this data you substitute V1 and that is our volume here. Okay, then substitute 28 divided by 22400 into this answer divided by weight of organic compound that is given. What is the weight of organic compound? That is 0.3. Okay, into 100 substitute and find the answer. Numerical calculations I am not explaining. Okay, you can conduct. So that is question number 30. Question number 14 I am giving it as totally a homework because it is dealing with the Geldal's method. We have done one question in this particular session. Okay, so find the answer for question number 14. I am not giving the data. Formula I explained already. Agree? Question number 15. What is a non-benzene aromatic among the following? Non-benzene means it doesn't contain benzene. That's it. Aromaticity, Haeckel 4n+2 rule that you are learning. And in that area you are seeing two types of aromatic compound. One having benzene structure called benzenoid, other having non-benzenoid. Okay, that also I am leaving to you. Okay, benzene is there, naphthalene is there, tropone is there, pyridine is there. Tell me the answer. That's all. Next step. An alkane containing primary, secondary, tertiary and quaternary carbon. That by a trial and error method only you can find it. An alkane containing all the 4 types of carbon. Okay, I am selecting option 2, 2,2,3 trimethyl butane. First option is 2,2,3 trimethyl pentane. Let us write 2,2,3 trimethyl pentane. Pentane contain how many carbon? Pentane contain 5 carbon. And in the first option 2,2,3, 2,2,3. Trimethyl pentane means every other valencies are satisfied by hydrogen means CS3. Here there is no valency. 1 valency left behind, 2 valencies left behind. This is the answer. Because this is a primary carbon, primary carbon, primary carbon, primary carbon, primary carbon. This is secondary carbon, this is tertiary carbon and this is quaternary carbon. So first option itself is answer. Agree. Next, identify the correct name among the following. That means 4 options were given, you have to identify the correct name. So some mistakes may be the first option 2-methyl 3-ethyl hexane is a wrong answer. Why? Because alphabetically E comes first, then only M. Okay, so that is a mistake, number 1. Number 2, 2,2,4 trimethyl pentane, 2,2,4 trimethyl pentane, 2,2,4 trimethyl pentane. Yeah, suppose I am placing one methyl group here. So writing 2,2,4, not 2,4,4. 2,2,4 is correct. So that answer is correct. So let us analyze the next 2 also. 2,4,4 trimethyl pentane. Suppose I am numbering from here 2,4,4. That is wrong because whenever we are selecting the direction of numbering, you have to select the direction in which maximum number of side chains are getting minimum number. So third option is wrong and third option is exactly the reverse order of the second option. Second option. Question number, option number 5, 5-ethyl 3-methyl heptane. 5-ethyl 3-methyl heptane. Heptane, what is heptane? Heptane contain 7 carbon. 1, 2, 3, 4, 5, 6, 7. Okay, 5 means 1, 2, 3, 4, 5. 5 ethyl and what is that? 3 methyl. 1, 2, 3. This is not possible. Why? Because ethyl and methyl both are in the same location. Both are in the same location means you have to select the direction in which alphabetically you have to give more priority. Agree. So it should be named as 3-ethyl 5-methyl, not 5-ethyl 3-methyl. So that is also wrong. So our answer is option 2. Then question number 18, another IUPAC name. It's a compound given as a branched structure. I will draw. Listen. The branch. This is the molecule given and tell me the IUPAC name. Select the longest chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I am selecting this long chain. 1, 2, 3, fourth position starts branches, 1, 2, 3, third position starts branch means this is direction. So the name 3-ethyl 4,4-dimethyl heptane. Okay, you tell me the option. 3-ethyl 4,4-dimethyl. Agree. Next one, hyperconjugation. It's a special type of resonance operating between an sp3s sigma bond with a positive carbon or a radical carbon or a pi bond. Okay, by taking a lot of time we have explained the concept in the normal class. So it's an interaction between sp3s sigma bond with an sp2 carbon. If this positive carbon, radical carbon, pi bond, all of them have the same common feature. All of them contain sp2 carbon. So sp3s sigma bond interacting with the sp2 carbon. Okay, positive charge means an empty p orbital. Agree. Okay, then pi bond directly, pi bond of double bond actually, not triple bond, pi bond of double bond actually, then only it is in sp2 hybrid state. So that type of special interaction is called hyperconjugation. It is having a short range influence, but in that particular range it is so powerful. With respect to alpha only it can act, not to the beta or gamma location. Okay, so among the given options, sigma is the first option. It is actually inductive effect. Polarization of a sigma caused by the polarization of adjacent sigma is called inductive effect. Second option is correct, sigma pi interaction. Why? Because sp3s sigma bond is interacting with the pi bond also. Then 20th question, a species that contain sp2 carbon. The species are carbanion, carbocation, carbon free radical, and you know carbon free radical and carbocation have sp2 hybridization, and carbanion, that is an sp3 hybrid state. Okay, so that is a clue, you find the answer. Okay, so these are the 20 questions from first basic principle of organic chemistry. Okay, next chapter is hydrocarbon, and from the next chapter onwards there are so many connections with the second year chapters. See, when you are learning organic chemistry, there are mainly two headings, one is preparation and other is properties, mainly chemical properties. Physical properties are easy to remember. Okay, preparation means suppose you are learning the chapter alkane, that is the first chapter, alkane. Preparation of alkane, you have to study how you can prepare alkene from alkene, ENE. From YNE how you can prepare, from haloalkane how you can prepare, from alcohol how you can prepare. So from each and every family you know, actually how many families you are learning, alkane, alkene, alkyne, then second year haloalkane, alcohol, phenol ether, aldehyde, ketone, carboxylic acid, amines. These are the chapters you are learning. So from these functional groups how you are preparing alkane, alkene, alkyne, like that you study, so that you can establish a connection between the functional group, and that connection when once it is accomplished, then organic is very easy. Properties means suppose you are learning the properties of alkane, you are going to learn how alkane can be converted to alkene, to haloalkane, to alcohol. When you are learning the preparation of alcohol, you have to learn alcohol can be prepared from alkane, alkene, alkyne, if method is there, haloalkane, aldehyde, ketone, carboxylic acid, like that. So when you are studying the properties, how you are converting this alcohol again back to alkene, back to alkyne, okay, back to aldehyde, back to carboxylic acid, like that. So actually organic chemistry content wise it is only 50%. Okay, preparation is actually you are learning in another side as property of some of the compound. So that is the beauty of organic chemistry. When you are once falling into that track of organic chemistry, that area is very easy. So from hydrocarbon onwards, make it thorough. Okay, so that's all for today. Today means this basic principle, some questions only, okay, only for a revision mode. So study it, tell me the answers I have given as assignments for you, tell me the answers. Okay, the next will be hydrocarbon. Namaste.